In this question, we're given a diagram which shows two right-angled triangles, ACB and DEB. We're told that the length of AD is equal to 9 cm, the length of DE is equal to 2 cm, and the length of DB is equal to 6 cm. We need to calculate the length of the line CB, giving our answer correct to 2 decimal places. Now we can label the information that was given to us on our diagram. We've been asked to calculate the length of CB, and we need to think, how might we do that? Well, let's think about what we've been given in our question. We have two right-angled triangles, and so when you see right-angled triangles, the first few things that might come to mind would be Pythagoras' theorem or trigonometry. And so it's likely that we might use one of those. But notice here that we have two triangles, and when we have two triangles and we're given information about both of them, we might be talking about similar triangles or congruent triangles, or some relationship between the two triangles that will help us find out more information. Now we can draw both of these triangles separately in order to help us understand. You can see here that we have triangle ABC and we have triangle DEB. We can also see that this angle over here would be the same in triangle ACB and the same in triangle DEB. Now we can see that both of these triangles have identical interior angles, but they have different sides. Now using this information, we can see that these two triangles are similar. And so similar triangles are triangles that have the exact same shape, but they might have different sizes. For example, the length of the sides may be different. But now for them to be exactly the same shape, all the length must be in proportion. What this means is that there's a scale factor. If we multiply the length of one side, we need to multiply the length of every other side by the exact same scale factor. So if the length of AC, for example, was 4, that means we multiplied this by 2. And so that means the length of AB would have to be 6 times 2, which is equal to 12. Well, now that we understand the concept, let's think about how we might find the length CB. The first thing that we need to do is to find the actual scale factor between the two triangles. But right now we don't have any length in this triangle, and we need at least one length from both triangles in order to find a scale factor. But we can find out the length AB, because if we look at the original diagram, we can see that the length of AB is equal to 9 plus 6, which is equal to 15. Now we have the length of a side on triangle DBE, and we have the length of the same side on triangle ABC. Let's use this to find the scale factor. We can say that 6 multiplied by the scale factor is equal to 15. And dividing both sides by 6, we can say that the scale factor is equal to 15 divided by 6, which is equal to 2.5. Now we've found a scale factor of 2.5. Our final answer should be the length of line CB. Now we can see that the line CB is the corresponding length of the line EB, and if we know EB, we can multiply EB by the scale factor in order to find CB. We have enough information to find EB using Pythagoras' theorem, like we said before. We know that a squared plus b squared is equal to c squared, and c is always equal to the length of the hypotenuse. We can say that 2 squared plus be squared is equal to 6 squared. And so the length of line BE would be equal to the square root of 6 squared take away 2 squared, which when we put into our calculator, we'll find that the length of BE is equal to root 32. Now that we know the length of line BE, we said that we can find the length of line CB using the scale factor. If BE is equal to root 32 centimeters and the scale factor is equal to 2.5, we can say that the length of CB is equal to root 32 multiplied by 2.5, and when we put that into our calculator, we'll find that the length of CB is equal to 14.14 centimeters to 2 decimal places. And so we've now found that the length of CB is equal to 14.14 centimeters. Now this question is worth 4 marks. We get the first mark for finding that the scale factor is equal to 2.5. We get the second mark for finding that the length of line BE is equal to root 32. We get the third mark for the correct process to find the length of CB by doing root 32 multiplied by the scale factor of 2.5. And we get the fourth mark for the correct final answer that the length of line CB is equal to 14.14 centimeters to 2 decimal places, allowing us to get the full 4 marks needed in this question.